Hi, so my name is Antonio Goncalves, and my partner is Seth Kempke. We're doing 3.5 chemical reaction types and their reactions. We chose to do the fourth experiment called double displacement.
So double displacement in this case is pretty much when you take two compounds, in this case nickel 2 chloride and sodium hydroxide, both of which are aqueous solutions, and you put them together and those ions replace and combine with the other ions. So in this case becomes nickel 2 hydroxide and sodium chloride. Um, Nickel 2 hydroxide in this case becomes a solid because it's not soluble, and sodium chloride continues to be aqueous. Uh, in this case, we have 1 mole of nickel 2 chloride aqueous reacting with 2 moles of sodium hydroxide, which is also aqueous, yielding 1 mole of nickel hydroxide, which is a solid, and 2 moles of sodium chloride, which is an aqueous solution.
So the materials that we're going to use for this experiment is going to be two 50 milliliter beakers, one thermometer to measure the temperature during the reaction, 50 milliliters of 1 molar sodium hydroxide, or NaOH, which equates to 0.015 moles. And we're also going to use 6 milliliters of nickel 2 chloride, which also equates to 0.006 moles. This means that the nickel 2 chloride is going to be the limiting reagent of the reaction. So we're going to go do the experiment on Late Night Labs now. So first what we're going to do is take out the two 50 milliliter beakers, place them on the bench. Then we're going to take out the thermometer to measure the temperature. So now we have the 1 molar of sodium hydroxide, which we're going to place inside one of the beakers with 15 milliliters. Next, on the second beaker, we're going to use the nickel chloride. We're going to put 6 milliliters. And as you can see, the sodium hydroxide is a cloudy white liquid, while the nickel chloride is very green. So now
we're going to zoom in to see the reaction a little further and see what really takes place. So now we're going to combine the nickel 2 chloride with the sodium hydroxide. And we're going to pour all of that into the other 50 milliliter beaker. As you can see, there is a solid left after the reaction. That is going to be the nickel 2 hydroxide, and what is left with the liquid is sodium chloride, and as you can see, it's very cloudy. Also, if you notice, there was also a change in temperature during the reaction. It went up to 22.1 degrees Celsius.
So the observations, to repeat what Seth just said, there was a temperature increase during the reaction, but as time goes on, the temperature returns to room temperature once everything reacted. You can see that a green solid was formed, which was the nickel 2 hydroxide, and the liquid becomes the cloudy, which around the same hue that we started with in the beginning of the reaction.
So in the end, to recap, our balanced equation is nickel 2 chloride, 2 moles of sodium hydroxide, both of which are aqueous, and the products are nickel 2 hydroxide, which is a solid, and 2 moles of sodium chloride, which is also an aqueous solution.
Thank you for listening to our presentation today. Hopefully this helped you understand double displacement a little better.